Um, my name is Jen Wei. My team and I are responsible for developing and deploying 3D object detection system with Lidar point cloud with VEERUM. So today I'm going to share with you my experience of how we went from zero to production ready in 9 months. Okay. So for the rest of the presentation, I'm going to organize it in the following way. I will introduce you to Virum. I will talk you through our use cases and the client's expectation of us. Then I will show you a few examples of the challenges that we encountered, how we move forward, lessons learned. So this is all what happened in the past. Then I'll talk about what's coming next. So my intention for this presentation is that I hope that you can find there some takeaways that will help you to achieve whatever your goal is. So who is Virum? Virum is a award-winning cloud application to unify your asset data. All right, so who are you? So our clients are large industrial projects, gas and utility companies, mining companies, and oil and gas companies. So what kind of data do we unify for our clients? So our data are heavily visual. For instance, we have KD models, computer aided design, stands for KD, GIS and reality scans, all the asset information and documentation, as well as real-time Internet of Things data. And so we aggregate all those data and then we present them in a highly visual way. So what you can see on the right of the screen is kind of like an example of what you find if you sign up with us. And we do it all in 48 hours. So we are very easy to use. We are very lightweight. So how does that relate to our use case? So next, I'm going to show you just a little bit more detail about our product, and hopefully that'll give you an idea about how that all connects to our use case. So now what you are, I would say, 3 illustrations on what you might find on our platform. As you can see, the nature of, I guess, the projects of our clients, they are super large industrial projects. I said they are very complex. And really what you'll see is just an example, right? So what we deal with oftentimes is 3 times as complex. So one of the challenges our clients are facing is the silo of their data. So I'll give you an example. You know, those big industrial projects, they have hundreds of thousands of equipments, but it's not clear which equipment is where. It might sound kind of counterintuitive. How come you're not knowing your own equipment, right? But realizing those big projects take years or tens of years to build, and the equipments are built as they go. Sometimes you have to change equipment, right? Because they get old, you have to replace them. And there is this lagging on the documentation, or sometimes it's lack of documentation. So this is where Virum provides value, because we come in and we present all this data, like I just said, in a very visual way. Therefore, you can be on site without going physically to be on site. And one particular way that we help our client, we add value is what we call an object tagging. This is what the example is, this pink cuboids you see on the upper right of the screen. So it's very simple. We identify all the equipments, and then we link the documentation information with the equipment so that our client, apologize for the background noise, I live very close to a fire station. It will go away, I promise you. So that our client can do a really quick filtering. So why is that important? Because some of the equipment, for instance, safety pressure valve, there are regulatory requirements that you have to know where they are. You have to make sure they are up to date, their maintenance is up to date. Otherwise, you might be facing huge economic or safety consequence. So this tagging, this searching and filtering, imagine without this this feature, right? So you have to manually go on site and search for those little equipments, which may not be solved just by throwing more people. So this is an example of how we add value to our clients. So now, how's that relate to our use case? Well, right now, the tagging is done manually. So what this initiative, the R&D group, what we are trying to accomplish is really to automate the whole process. Specifically speaking, we want to tag every equipment on our platform, whether it's from a CAD model or a reality scan. Obviously, our clients are very interested in this initiative. However, they are super excited, but they are also skeptical. So the milestone they put for us is just, can you guys train an AI algorithm with custom data in a production environment? So you notice there are 3 components: an AI algorithm, they don't care what that is, right? With custom data, don't give me any like fluffy data. I need you guys to do it on our data, as complex as you see that is, and in a production environment. So I want the real deal. So this is the milestone that our client has gave to us. Now, I know many of you are data scientists, so you might notice there was no mentioning on performance. There's no mentioning on any performance metric, right? So you might be thinking, well, that sounds really easy because there is no performance threshold. So does that mean Jen come here to just give us an impossibly easy data science project? Well, we shall find out. So yes, so here is how it all started. So this is my expectation on how the project would go. Based on my past experience working on those, fast iteration, experimentation type of data science project. So step number 1 on the data side, let's find a sample data set. Step number 2, on the model side, let's install some library, maybe AutoML tools, right? Because it's 3D visualization, and then learn how to use its API. Step number 3, let's start running experimentations on Google Colab. Step number 4, right after we have our initial training results, let's iterate from there. AKA, in data scientists' language, let's beat the performance metrics to death, whatever one you choose. Okay, so this is all good. This is the expectation, pretty straightforward. So next, let's look at the reality of how we started. So I had a chat with my boss about, I was like, well, where's my data set? Where's the sample data set? And we just chat about what needs to be done. And here are the following of what I found out, what needs to be done. So on the data side, so I joined the company in April of last year. At that time, we were still waiting for clients' approval to use their data for AI training. In other words, we don't have any sample data set. We didn't have any sample data set. Also notice that because we are an online platform, the data is stored for our platform, right? So they are not necessarily, well, they definitely are not there for your AI program to use right away. So we also need to find a way to extract customer data from our platform. Meanwhile, because we didn't have customer data yet, meanwhile, that just means meanwhile, we need to find a public data set. I should say find public data sets to start training and experimenting with our model. Speaking about model, at that time, we had to define the problem because even though we knew our realm is in the 3D object recognition, 3D object recognition is an umbrella of many branches, right? It could be classification, it could be object detection, it could be semantic segmentation. So which one of the branch are we gonna tackle? That is a fundamental decision we have to make. We also realize that 3D object recognition is an active research area. So unlike 2D image recognition, there are golden standards. There are your go-to algorithms or go-to architectures. It's not the case with our use case, which just translates to we need to research the state of art and decide on the right architectures. Or I should say realistically, it's the right architectures to start experimenting with. On a little bit lower level, we also have to decide on, do we want to go with TensorFlow implementation or PyTorch implementation? And then on the compute side, I quickly realized Google Colab is not going to cut it. So we have to decide on, do we want to get an AI laptop with all the prefabbed libraries and tools, or do we want to use cloud GPU, or do we want to use local GPU, and then install everything from scratch? And I'm not done yet. I'm not done with my to-do list yet. Then we realize, with the complex of any machine learning algorithm or machine learning projects, the nature of it, we better get organized, which means we have to deciding on the process tracking, monitoring, and the management tools, as well as the process in terms of code, data, and experimentations. And I'm still not done yet. And everything in the following diagram. So I know you're all probably very familiar with this program, this diagram. Out of the interest of time, I will not go into details on everything. I will just say this diagram plus the curveballs. All right. So now you might wonder, how has it been going? You just showed us this laundry list of to-do list, this laundry to-do list, right? So I was very glad to share with you all, by Christmas of 2021, we were production ready. So sometimes people ask me, what does it take? Well, I think people always ask, what does it take to do X, Y, Z? And I'm going to share with you what it took for us to do X, Y, Z. So for the rest of the presentation, let me share a few examples of why this project is so challenging, how we overcome the obstacles and was able to continue progress. All right, so why is this project so challenging? Or at least it was so challenging for me. I will say one of the reasons is any data science project is, at the end of the day, is a piece of very complex software. So it is embedded, the technical challenge is embedded in any data science or AI projects that you decide to work on. And here's the example. I'm sure you all are very familiar with how to install dependencies, and I'm sure you all installed a lot of dependencies. So in my experience, It usually goes like this: pip install, like scikit-learn, pip install this, pip install that, and maybe a handful of pip install, you're done. This one is just a little bit different. This one, everything I'm giving you, so what you see on the right of this screen is a little sample of what had to be installed in one of the architecture that I tried. So in addition, I mean, it's not, it's more than just a handful, obviously. But I actually soon found out one of the headaches of installing dependency, which nobody ever told me, was to set up a virtual environment and toggle between Python 3.6 and 3.8, I mean, different versions of Python. And that virtual environment is not Anaconda. So it's like a real virtual environment. And some of the dependencies can be installed via pip, but not all of them. One time I had to install a dependency, which is a GitHub repo, but then you have to use their Docker image if you choose to use PyTorch 1.3 plus. And to be honest, who would use a PyTorch any lower than 1.4, right? I also had experience with out of you, and then after feeling like I have reached the bottom of the internet, the solution apparently was to rebuild your entire virtual environment, which means you reinstall all the dependencies you just did. And I should mention that, you know, I talked about we had to make decisions on how are we gonna, you know, go with our GPU. We decided to go with local GPU. We have a local GPU cluster that I remotely remote into, which means there is a possibility that I have to do all of this on each of the GPUs. So that's yeah. So I don't know what else to say. Lots of fun. So how did we overcome this obstacle? The solution we took was to put it in a container. Now, I know this is very counterintuitive. I know this is not, probably most of you don't do, because the conventional wisdom that at least I have learned is you do your experimentation in your local machine. And once you're ready to deploy it, you put it in a container, you give it to the ML ops team and you're done, right? But we decided to develop our ML code inside the Docker container. I want to say the solution. I want to say the solution makes sense because Docker container, at the end of the day, is a virtual environment. I also want to say that I feel very great. I feel very, almost I want to say I feel very proud of us taking this route. This requires a lot more work, a lot more upfront investment, but it made such a difference in terms of helping the project to go, you know, smoother in the long run. So why? Well, what are the benefits of developing your ML code inside the Docker container? So in the short term, I would say in the short term, it made our code very portable. It is easy to experiment on different architectures and debugging. So in other words, it really solved all the challenges, all the laundry list, right? I just showed you a couple minutes ago. In the longer term, it's much easier to build the complexity and troubleshooting as you develop your system, as opposed to do your system, maybe a little bit messy, maybe you forgot what you did, but then at the end, push it to a different team and give them this laundry list of laundry to-do list. And then because of the benefit of long-term and short-term benefit, because of the long-term and short-term benefits, in aggregation, it makes things a much smoother integration to production. And I'm going to kind of zoom in a little bit and show you why I said what I said. So let's look at how we build complexity of our system. So to the left of the screen is our code. So they reside in your GitHub repo. So I mentioned, sorry, give me just 1 second. All right, as I mentioned, we started out by putting the model in a container. And then we said, oh, wait a second, the data collection is its own process that needs to go into a container as well. And then we realized there are other services needs to go to containers. And then once you have a container, once you have a container that requires multiple images, you use Docker Compose to orchestrate your services. And then once we go to prod, we leverage all the Docker files that we developed individually for our multi-stage build. And then to the right of this screen is what you would find in storage. So those are like physical, in your physical, well, actually either physical storage or cloud storage. So what you could find there could be raw data or any data that you get from the data collection container process. You could find the process data. So data that are processed, maybe you're processed for data augmentation, not something that needs to be processed by your AI algorithms, as well as the training output. So things like your checkpoints, all the parameters of your model, as well as your evaluation results. And we kind of communicate in and out of the Docker container as the following, as the green arrow indicates. We grab raw data through data collection, and then we feed the raw data into the model, and the model will do its own magic, right? And then it saves the process data and the training output back to the storage. So yes, as you can see, this is, I won't say this is a bare minimum, like straw man diagram of what we build. But I think here you can see there is a clear separation between data and the model. And I want to kind of zoom in this separation just a little bit more. So we then look at, okay, on the data processing bucket, it's really not a container anymore. You could be getting your data through API polling, so that's API communicating with our backend, or you could do it through some data management tool. So we use DBC. It really could be anything. And then on the model training side, we decided, okay, let's just separate. Let's just compartmentalizing what we do, our code, even more. So we further separated a project into template bucket and the tools bucket, more like a template directory and tools directory. So what does template mean? Well, template really, it means it could be a template data set. It could be a template of model architecture. And the tools are really for configurations. So they could be data configuration and the model configuration. So here you can see there are really two layers of separation further down, right? So why do we do that? It's really easy. I keep thinking, it's the hard thing that we chose to do that took us far. And then the question is, why are you doing this? It's so much easier to just write a code with injecting data, and then whatever your model architecture is, and it will flow really smoothly. At the moment, why are we doing this? Well, this is all for later efficiency of us doing experimentation. So for example, if I ever have to change a data set, when I say data set, I don't really mean like, let's say like 1,000 training sample versus 5,000 training sample. When I say I'm changing a data set, I'm really saying the input format has changed. For instance, some data set might require you to have 2D images, 3D Lidar point cloud, and some text files on the calibration, meaning like how to communicate between 2Ds and 3Ds label, versus this other data set, only 3D Lidar point cloud, right? So imagine if you have to now digging into the code and say, hey, we don't have 2D, and take that piece out, or put that piece back in. That will be a hassle. That will be so time consuming. So this is why we decided to separate everything, and we decided to use a config file. So at the end of the day, if I want to change a data set, or if I want to change a model architecture, so that could be some model has 2D backbone, some model has 3D backbone, some model has both. So if I want to change that, all I have to do during training is to swap out a different config file. So once everything's set up, if I really want to change a different model architecture, how long does it take for me to kick off a new round to do that? 15 seconds. I think you can do it in 5 seconds. I'm a very slow typer, so that's why it takes me 15 seconds. All right. So another theme at this point that at least I start to feel is the need to get organized. So let's do it. So let's just look at what are the other things that we need to get organized. So we realize there are data management, there are experiment management and tracking. There is this whole data pipeline. And then there is this secret management. Although I would say secret management did come later, did come like now that we're really like training in prod. So yeah, so this is an example of how we kind of encountered a curveball, which is as small as install dependencies. And we decided to kind of build on the complexity, but also put in the work to set up a system to really, to just allow us to be more efficient later down the road, but also I would say gave us a chance for us to grow, to scale up, because you can see the things really gets tangled. Things can get tangled really quickly if you're not thinking long term from the get-go. So that was an example of technical challenge. Now I'm moving to an example of intellectual challenge. I want to say, actually, this is not necessarily an example, a challenge, because I actually quite enjoy the intellectual challenge part of things. I find a lot of satisfaction that in order for me to even just do this job, I have to challenge my own assumptions. Everything I thought I know was greatly challenged. I always have to think deeper on what this is. Do I really understand it? Have to understand the algorithm as opposed to just understand the API, which I find very satisfying. So here I'm giving you an example. Now, I mean, I realize 3D object detection is kind of like a niche. So it wouldn't help anyone if I'm, launching into all those architectures. So I decided to just show you an example about the model performance metric. I think everybody understands it. It's quite intuitive, but also it's just a fun thing to work useful. I hope you find it fun and feel like you've, I mean, you probably already know this, but if you haven't, I'm hoping that you feel like you learned something new. So yes, now we talk about model performance. And I know that you're very familiar with how in terms of binary classification problem, right? So you know on the left, here you see is the confusion matrix. And you all know based on the actual value and the predictive value, there are you can categorize your predictions into true positive, false positive, false negative, and a true negative. And then you can calculate your precision and recall F1 score or F2 score as the formula indicated just above the confusion matrix. So to the right are a list of questions that I actually asked myself when I had to evaluate the model performance for multi-class object detection problem. So actually the first question I asked myself was, is that even a classification problem or is that a regression problem? When you see multi-class, so multi-class, right? Because what if we have like when multiple objects and the multiple detections of the same class, which one should I assign to which? What if one object that overlaps with multiple detection? And on the other hand, what if I have one detection that overlaps with multiple objects? Well, this is really bad, but you know, what ifs, right? And also, what if one detection overlaps with one object? The overlap goes well, but the class is wrong. And how about the detections that don't overlap with anything? Furthermore, how would I define false negative? Do we even count true negative? In other words, what does negative even mean? Right, so here is, so here's how we work things out. I find it quite interesting when we have, like when I have questions like this, to think in terms of case study, to think in terms of like what bugs me. So the first thing that bugs me was that a classification problems are a regression problems. And I realized it kind of regression, but not a real regression, right? Because it's not the closer the better, but rather good enough is enough. That just tells me I need to decide on an IOU intersection over union threshold. Another thing bugged me was, ooh, what if I have like one detection overlaps well with some ground truth label, but the class was wrong? In which case, let's just filter on the object class and the detection class, which means if I choose a class, could be safety of, everything I see, whether it's your ground truth label or your detection, only belongs to that class. So take care of that. Then another question I asked myself, well, what if I have one object and I end up having multiple detections? In which case, you just choose the best detection. And how do you choose the best detection? Well, there actually are multiple ways to do it. You could choose the best detection, which you call it as true positive, as the detection with the highest IOU. Or I've seen other people choose it with the highest confidence score. But either one, you pick the winner in such case. And then the losers, which means the detections that just didn't come on top, become your false positive. Now, how about the negative? You know, I realize in object detection, because your output is a bounding box, right? Whether it's 3D or 2D, anything you output are actually positive. Anything you don't put out is negative. So in which case, false negative means you should have put something out, but you didn't. Okay, well, in that sense, you know, false negative is the number of ground truth objects minus your true positive. That's the easiest way to calculate false negative. And there's no need to calculate false true negative because everything you don't see is true negative. And then you proceed with precision and recall as usual. And then for object detection, there is some, I guess, extra caution that you want to take. So things like you want to vary your confidence scores, that way you get your precision and recall curve. But you want to add this extra layer, which we actually is easiest way to describe it is like the smoothed out precision curve, which is you choose a recall curve and you choose the highest precision level that is above this recall curve, this recall level. So the reason for doing that just so that you cannot cheat the system. So it's just in order for an algorithm to do well in such a metric or in such a curve, you have to do well in every recall level. So just one extra layer of scrutiny, I would say. And then you average all your precision, all your precisions to get your average precision. So that as a whole give you one single performance metric called average precision. So this is all fun. I'm sure like you would really enjoy this thought process exercise. But I wouldn't say the problem. The challenge with average precision is that it's not very actionable. It's very difficult to explain to stakeholders, which pays us. So you want to make their life easier. So meanwhile, I want to say, as I was figuring out this average precision metric, I also wondered, what can I do? What can I present to our stakeholders in the way that A, they understand what we are doing, and B, they can make decisions on what they want to do with what we provide to them. And interestingly, this is what I like about this, doing this exercise. Interestingly, as soon as I figured how to define true positive, false positive, and false negative in a technical way, I find it very easy to explain them in intuitive ways, because your true positive really is just your correct detection. Your false positive is your incorrect detection, and your false negative is your missed detection. So going back to what we do on our platform, your true positive is just the correct pink bounding box you put in, which means you don't have to do anything. You just get the pure benefit from it. False positive means you put some pink bounding box, there's really no object of interest there, and you have to remove it. False negative means, sorry, just give me 1 second. Okay, false negative means there should be a bounding box, but there wasn't, which means you have to hire people to manually put bounding box in. So you can see false positive, false negative has some cost associated to it, and false true positive just gives you pure economic benefit. All right, so that is the end of the the example of the intellectual challenge side of this project. So now I'm moving to mental challenge, to the mental challenge part. And I have to admit that I actually changed the slide last night. I was very sick this whole week, and I didn't have the energy to really think things through. So I apologize if it ends up being rambling and not polished, but my intention of me making this last minute change and not going back, I'm not even looking back, is because I, perhaps selfishly, I want to give something back to you all. I think I want to give something back to the younger me. In which sense? In the sense that I don't fit into the stereotypical golden child bucket of who should be working in AI. or data science in general. And when I was younger, I didn't see people with background like mine. And I just really wish that I could hear something that helped me with my own journey. So hopefully I'm able to provide you an example of you don't have to fit into this mode to work in AI. Or I want to offer you some words of encouragement, but I also want to give you some realistic tools that you can use and a realistic expectation on what it takes to work in AI. So without further ado, let's get into it. All right, so why is this mental challenge so hard? I want to say that, if you look at what I do, from the outside, it's, there are technical problems that she needs to solve. She's solving technical problems. She's solving intellectual challenges. But, it's like she's conquering these mountains. I'm using this quote. It's not the mountain we conquer, but ourselves, because I'm a climber. So this quote really resonates with me. So you might look at someone who's like conquering the mountain from the outside, but I will say from experience, what I have really been conquering in the last 9 months and my entire stay was really just conquering myself. Precisely is my fear and my own limiting beliefs. Like I said, I don't fit into any of those stereotypical, I don't know, persona who you would put on a pedestal. I am not a computer science major. I am not a software developer. I am not awfully young. I want to say I don't give people that impression that I'm super duper whooper smart. I probably just look like an average person that you meet on the street. And none of that is the problem, I would say. The problem is I'm also not very confident. I'm actually very unconfident. So I also was told a lot of no. I got rejected a lot. And at one point, I convinced myself I cannot do AI. Maybe I can do structured data. I'm a mathematician. AI is just too much coding for mathematician. But then somewhere along the road, I decided that I'm gonna do exactly what scares me. So that's one of the reasons I took this job. And I think at this point, you're probably gonna say that's all woo. It all sounds fancy and dainty. Face your fears, challenge your limiting beliefs. Yeah, I know all that. But exactly how you do it. So now I'm gonna give you 2 examples of exactly how I did it. I want to say that I keep seeing there are chats popping up. I'm not able to really see it. I apologize, but I promise you I'll get to all your questions at the end. By the way, I'm also not very techy. I actually do a lot of techy stuff for job, but if I'm not working, I'm very old school. So I apologize for that. So I'll give you 2 examples. So I remember when I had to build a Docker container, which was the first time I ever built a Docker container, which also was a very advanced version that I had to build. My boss asked me, if you have any if you have any question, let me know. And I said, sure, but let me give it a try. If I really struggle, I will definitely let you know. But I actually really just wanted to push the whole thing to him because I'm like, I don't know how to deal with this. But then I told myself, it's really good that you have a team who's always got your back, who will be there for you when you need them. But wouldn't it be nice if that team is yourself. And also, you get the whole internet behind you. And anything you can ask a person, you can ask Google. So I just decided to Google. I pretty much Googled my whole career. So that is one example. The second example is I got really curious how the deep learning algorithm works. Except I never used PyTorch before. I used very little TensorFlow either. So, and then I realized, you can have this, I can have this ambitious goal of, figuring things out, which really means in terms of climbing. If you want to climb V15, you need to have strength, skill, and experience. And how do you get strength, skill, and experience? Is by doing everything below. It's climbing everything below V15. So translates to work. That means I have to do everything that the job requires, whether it's changing the algorithm or not, because I believe everything I do will only build strength, skill, and experience for me. And I definitely will say that's what keeps me going. And I told myself, every time you overcome an obstacle, you get stronger. There's no question about it. But also, I'm aware it doesn't get easier. I don't want you all to think, oh yeah, you can work in AI. Anyone can work in AI. Sure, everyone can, but you have to put in the work. It also doesn't get any easier. You get stronger. So I just tell myself, do the best you can. There will always be people smarter than you, stronger than you, more skilled than you, but that's not the point. The point of what I do, why I do what I do, is to push myself. And you know what? At one time, I would not be pushed anymore. At one time, there will be absolutely no more that I can do, which is a good sign, because that means I have reached my potential. So y'all, coming from someone who's always put other people on pedestal, this is what keeps me going. It's not about being better than so-and-so. It is all about doing my best. So that's the end of my ramble. I hope it's not too bad. And if you haven't fallen asleep, please allow me to summarize all the lessons that I learned so far. So lesson number one, do things not because they are easy, but because they are investments. Lesson number two, don't assume you know the answer. Always check. Last but not least, when things get hard, remember that we can do hard things. All right. So next, change theme, where we are going. So it's very simple. We are going to generate some synthetic data. So I'm super psyched about this new endeavor. And I would love to connect and learn more about your experience in this topic. And thank you all for your time and attention. I hope that we can connect. And I hope that I can get a chance to learn from you. And yeah, happy Friday. That's really the end of my presentation.
Thank you so much. Thank you so much, Jen, to share with us today, not only just like your challenge at work, but also like the mental challenge that you are going through, and for like all the people who are new to the field, or people are right now feeling a bit overwhelmed or scared with the challenge coming to them. And I really appreciate that you bring the talk today, and you are here today with us. So with that, I will start looking into the list of questions. We have a lot of questions for you. So I hope that we have some time to answer all of those questions with the time we have left. So let's look into all the questions from highest vote. So the first question that we have in here is that you mentioned finding public data set to start training the models if you don't have the data. Where do you find the data, and do you worry about the quality of those public data set?
No, quite the opposite. The public data set that we found were very high quality. Actually, I feel like it's probably going to be higher quality than the data set we would have, which impose a different type of challenge. So in short, the public data set I found, there are two camps. One camp is in the autonomous vehicle, the AV camp. The other camp is the indoor scanning. So in the AV camp, we have Wayman, we have KT, we have a couple more data sets, and then on the indoor scan, there is this RGBD scan. It's called some RGBD, and there's another data set called ScanNet. Version 2 is the good ones. Yeah.
So you think that is it because this is visual data, so it's like coming from the camera, so that's why there's more high quality published data on the internet compared to the other type of data? Do you think so?
I think so. Yeah. Yeah. So you're right. It's it's not camera. It's Lidar.
Image.
It's a 3D scan. But
Yeah.
you can it's kind of really analogous to camera. I think with those public data set, because they specifically, so the purpose of people put together those data set is for the researchers to develop state-of-art algorithms, right? In order to do that, they put a lot of effort on its quality. So in the sense that every data set, the XYZ range are more or less the same. For KT, every data set has about 100K data points. So those are highly, highly regulated and controlled. Versus for us, if someone go to a field and do a LiDAR scan, I think some of them are good, some of them are just not good. Like the range would be different. You may not have a standard number of data per scan, but also your objects, some objects, but really depending on how the objects reflects the sensor back, some are just very difficult to even scan. So yeah.
Okay, it's really interesting. I feel like it's very specific for this type, and it's great that there's like people who put those public data set online, so it's like save a lot of time from other researcher. And I think this is a very specific thing in the tech world, when we really honor like open source and like public contribution. So the next question that we have is, hi Jen, data science is a growing field. Do you have any advice to new data scientists who sometimes feel overwhelmed with the amount of information to know?
Yeah, for sure. I want to say, if you ask me how I feel about it, I don't know everything about data science. I absolutely don't. I think the best way, really, I thought about this a lot. I think sometimes it's just the hard part is to find a job. And I found that once you get a job, it's much easier to learn at the job, as opposed to, feel like you have to take all the classes and know all the branches. It doesn't work out that well. For me, I learned the basics. And then if there is a problem, I solve it. And that's how I learn it.
Yeah, it's like learning by doing it, right? So
yeah.
When you actually have to do things, you will learn it better. So the next question that we have is that I have a question about time management. You mentioned that containerizing your machine learning model and code has some upfront time cost. So how do you balance investing your time in something like that with the 9-month deadline?
Oh, first of all, we didn't have a deadline. I want to say that's one thing I find it's really unique about VEERUM is not a perfection focused organization. It's a progress focused organization. So when I joined the company, there was really no deadline. If you recall, the customer's expectation is, can you do ABC? There was no mentioning on when. There was no mentioning on to which degree, because this thing is so hard. The customer is like, I just don't believe this can even happen. So it was not so much about deadline. It's more like I found in terms of like, maybe I can, in terms of managing deadline of getting things done, since I'm so new to a lot of the work it's just communication. Sometimes I always tell my boss that I like to get to the bottom of the things, but if you think that I'm dragging for too long, things has to move, you just let me know. So it's about communication. In terms of managing deadline, I want to say I'm just lucky. I'm very lucky to have an organization that just understands the challenge.
Yeah. So actually, to follow up on that, even though it doesn't have a deadline, do you set like a mental deadline for yourself? Because if it's not working, there's some point that you would have to stop, right? So how do you like go about that?
It's actually very funny. I want to say it's really funny. I want to say I agree with the mental that time boxing things, because you don't want to drag forever. But I want to say, for me, most of the time it doesn't work. It doesn't work that way. The moment that I think about I need to get this done tomorrow or next week, everything goes wrong and I have no idea what is going on. But if I can calm myself down and just be like, this goes wrong, what does this mean? Can I solve it? And then there's something else wrong pops up, solve the next problem. It always goes faster than I had anticipated. So so the short is I don't really manage deadline very well. The only example, this is very funny. The only example I can give to you was, actually I met the deadline is, you may not know, I'm actually very competitive and to a fault. When I was just trying to change one set of data sets to another, like really wiping out the whole data set, I was looking at other people's experience, etc. And I saw one person, he's like, I'm thinking it's he, we did it in a week. And I remember that was Friday. That was day 5 for me. I'm like, I'm gonna do it. And then I was so ready to just like call it a day because it was Friday. I'm like, I'm gonna do it. What he did it in a week. I'm gonna do it in a week. And then I solved it. I'm like, I'm not gonna take Friday until I get it done. But that was the only example where deadline helped me. In every other challenges, and I've lost count on how many challenges I came across, it didn't help.
Okay, so I think one of the things is that, like, if you have understanding business, right, they know that this is not like an easy solution. It would definitely help with understanding like how much time does it take, at least from the business side. Yeah. So the next question we have is, what tools do you use for each of the segments on Get Organized slides? So for example, data management, experience management, and so on. Thank you.
Yeah, data management, like I mentioned, I use DVC. Experiment management, I use weights and bias. And then code is just GitHub.
What is the second one, experience management tools that you use?
Weights and bias, W&B, WANDB.
Oh, okay. Interesting. I will look into that after this. Thank you. Okay, so so the next question is actually following up on that. You mentioned using DVC for managing data. We use it at work and have some issues with it. Do you have any advice on good practice using DVC in collaborative environment?
I don't know what the issue is. I mean, I had some hiccups too. One thing I end up doing is in the config file. I think even though it's like in theory, you can have different, you can have different storage, and then you just use the .dvc to decide which data set you pull. But I realized I noticed like if I have there are two things. It's like this default, I end up updating this default config file to the storage that I actually want to pull my data from. I also end up remove all the other DVC file that I don't want to use. So just I kind of feel like sometimes it feels confused. Yeah, I definitely had issue with DVC because I pushed too many data sets. So that's how I do it. I don't know what exact the challenge is. Yeah, that.
So I think they was asking in collaborative environment. So like, do you use DVC when you're working with other people, or you just like use DVC in a project by yourself?
Yeah, I'm the only one. Well, I mean, I'm the only one use DVC, but then anyone can pull because we all containerized it. Anyone can pull it.
I think because if anyone can also push, then there will be like a overlapping in change in the push, and so you may not like be aware of what is the last version of the data. You may pull the wrong data.
Oh, I see.
Yeah.
Yeah, that I don't know. I'm not collaborating in that sense.
Yeah, no problem. I think probably one of the things people could look into is maybe like history. There probably some way to track the history of the push.
Yeah, I mean DVC does not control your version. Git controls the version. All the version control happening in the Git. So maybe looking into Git history. That's what I would do.
Yeah, that's probably help. Okay, so the next question we have is that, have you ever incurred moment when the models do not produce the results you want? If yes, how do you overcome the disappointment and keep trying? Thank you.
That happens all the time. I mean, there could be number of reasons. I want to say, I think the question is probably like the prediction results aren't good. Then I have to admit that we don't have enough data to have good prediction results. So I don't even expect anything to like making sense at this point. But I think hypothetically, you see, I think working with unstructured data is a little different from like working from structured data, in the sense that I don't really do any like feature engineering. So if things hypothetically, if things don't go well, the question I would ask is, what is your data set? You know, for us, because it's like this, you have to voxelize your data. Is your voxelizing, you know, do you have too many points in the voxel? Do you not have enough? Maybe do a few visual on what type of prediction you do really badly. Look at how well the model is converging. Is that overfitting? You know, all those basic things. But I do feel like to a large extent, the problem isn't on you or really on the algorithm. It's on data a lot of the times. Yeah.
Yeah, that's like a famous saying going around, like garbage in, garbage out. But it's like, so it's, I think for tabular data, it's more about like whether you clean the data enough. But like for unstructured data, it's just like if the quality is like not, or like if you don't have enough data, then you can't make any inference from it. It's just the nature of it. Yeah. So I think it seems to me actually is that you don't see the unfavorable outcome as like a disappointment, but more like a challenge. And you just like, you did like a bunch of like error analysis or like kind of root cause analysis to see, okay, what is the result? What is the reasons of this this like result, and try to tackle them more than.
Yeah.
So I think it's probably perspective in here that you try to look into a different than just, or like set your expectation, as you mentioned, right? Like in the beginning, you already knows that you don't have, you already think that you don't have enough data. So it's fine. It happens all the time. So you don't feel disappointed. It's like, I think it's also like a shock when going from school to actual real world. application, and then you realize that like it's not just like fit the model, get a good result, and just improve it from like 80%, 90%. No, it's like there's a lot of iteration going, and it's how it is, and just have your expectations there. Kind of thing.
If you want to be happy, lower your expectations. I'm serious about it. Seriously. But no,
Yeah.
school is so different. People keep asking me like, why is that the data science going to production rate so low? Well, because you're not in school anymore. Like, in school, everything is perfect. Everything's handed to you. In reality, nothing even exists. You have to hunt everything. It's day and night different mindset.
Yeah, it's actually it's proven. It's just like your expectation. If you meet the expectation, you are happy. So lower expectations, definitely. Okay, so we have let's do 2 more questions. I know we are at the end of time, but let's do 2 more questions. So the next question I have is how different it is for a data scientist to develop the model and Dockerize it in the Docker environment.
How different?
Yeah.
I don't think let me say, we are very lean team. I don't want to say small, I want to say we are lean. We have 3 people. So my boss and I, and a software developer. In our setting, there isn't. What I deploy is the thing that goes to prod. I would imagine it's different for bigger companies, but I don't know. I'm not working in a big team. So for me, no, there's no difference. So I want to say it's not so much about, your Docker look different because you're a data science versus the Docker looks different because you're a software developer. It's not like that. It's what the problem demands. It doesn't matter what your background is, what your title is. You do what it takes to get things done.
Yeah, I think that at the end of the day, that's what business care about and what you need to provide value for your company.
Yeah.
Okay, and let's go to the last question. Do you think working with image data created additional difficulties compared to working with tabular data?
So if I'm hearing you correctly, do I think working with unstructured data creates additional challenges from working with structured data?
Yes.
The answer is no. If you ask me about my personal feeling, I actually enjoy working with unstructured data. I'm very surprised. I actually quite enjoy it. I think for me, I have a lot of experience working with structured data, but one thing that frustrates me, maybe it's my weakness, is this whole feature engineering process. I'm probably gonna make a lot of enemies, but it just doesn't make sense to me because the whole reason, in my opinion, the whole reason that we use ML is because there are too many features to be handled by people. And then the whole process of feature engineering is to have a person to handle the feature, which just doesn't make sense to me. And in the past, I will do all those analysis and I'll use every single feature. I never throw anything out. So to me, it's like, what's the point? So it's just something I never felt satisfying. For me, if I do something, I have to feel good about it. It has to serve a purpose. And that process, I feel like I'm just going through the motion. So I just don't feel satisfied with that process, and which isn't something I ever have to worry about with unstructured data.
So you actually feel like you prefer working with the unstructured data compared to like structured data from your experience. Okay. That's definitely there's we actually have mentioned earlier through some of the other question is that you do see that there's some advantage also with working with unstructured data, right? Like there's a lot more available high quality public data that people have been contribute for researching in it. But definitely one of the other side that maybe occur is that you also mentioned is that the size of data is normally bigger. So to like process those kind of data, you need to think of like what kind of computational requirement that you need. You want to use it like building a local GPU, you want to purchase on like cloud computing and so on. So there's definitely two sides, definitely depends on your preference or what's your company need at the end of the day. Yeah.
Sure.
So with that, we really want to say thank you for you, Jen, to be here with us today, share with us your knowledge and your stories. We thank you so much for the presentation.
Thank you, everyone. Feel very honored to be here. Yeah, so hope we can keep in touch.
Yes, definitely. We hope to have you back at one of our meetup in the future.
Thanks.
Okay, I will stop recording.